Hey guys, today we are going to see Terraform remote state locking with S3 bucket using S3 native state locking functionality. So this new functionality released by Terraform in new version, which is 1.10.0, recently released or a couple of months back it was released. Okay, so what did it mean and what is the benefit of it? So you can save your cost, infrastructure cost, to have the DynamoDB, separate DynamoDB database for the state locking, what we are using currently or what you guys might be using, right? Unless you know this feature, right? So now we can emulate the DynamoDB, and without DynamoDB we can have the native state locking. Okay, so previously what we used to do, we used to use the S3 bucket as a backend, and our TF state file can be saved in the S3 bucket, and that's for state locking we were using the Amazon DynamoDB database or DynamoDB table, right? So where the state locks can be saved, okay, and acquire the state lock key and lock that state file while during the deployment of any developer while trying to deploy it, okay. So what will be happen, you might be already know this functionality. If you don't know, the look at my previous video where where I was explained how the state locking work, how the local backend work, and how we can convert that local backend to the S3 backend, and then how we can use the state locking to avoid the conflict between the deployments, right? Or how we can avoid the override the current deployment state, okay. So today I'm not going to explain that how the state locking work and how the backend can be set up, but today I'm going to explain the new functionality which is released by the Terraform 1.10 version, okay. So which is emulate your DynamoDB functionality, or we need not, basically we not require the DynamoDB anymore to enable the state locking using S3 backend. So what will be used for the state locking? It is simply use the S3 bucket, okay, native state locking functionality. So how it works, the native state locking functionality, it is simple way. So it will be acquire the lock. To acquire the lock, it will be create a .tf lock file in S3 bucket where it establish the lock functionality, okay, by the state file. So whenever you deploy any config or deploy any build, right? So during that or any action you are doing to the Terraform play, you can see the Terraform play, or you can see the deployment or destroy any functionality we are pushing to the Terraform. So it will be created tf lock file .tf lock file in backend, which will be provide the locking system, okay, the state locking system, okay. So let's see go how we can emulate the DynamoDB. So now no more you require the DynamoDB as a state locking system. So we practically going to see that how it's going to be work. Let's okay, now let's jump into the practicals, how we can enable the Terraform state backend, and how we can enable the Terraform state locking using the S3 native state locking, okay. So in left hand side, I have created already S3 bucket, and I have the backend folder under that bucket which will be store our state locking, and also it will be store the lock file. So when I enable the native state locking, so it will be create one file .tf locks whenever I deploy any or apply any Terraform config, or plan any Terraform config, or destroy any resources, okay, using Terraform. So I have written a simple block which is our regular block of code, backend code, so which I written. So bucket property, it will be declare what bucket you are going to be use, bucket name, and key will be your folder under that bucket, and terraform.tf state file will be going to be create on the in that folder. Okay, so this is more important property or like important attributes which I'm highlighting here. So underscore use underscore log file is equal to true. So when you use this parameter, it will be enable your state S3 native state locking system or functionality on the S3 bucket, whatever bucket we are mentioning. Okay, so basically this bucket will be used for store the state backend and as well as the state locking file. Okay, so let's see how it is going to be work. Okay, so to deploy the resource, I am creating the small bucket again, S3 bucket through this config file. Okay, and that will be used the S3 backend. Okay, so let's first check execute the command which is terraform init, initialize the backend first. Okay, so this will be quickly initialize the backend. Okay, so once the backend get initialized, what we are going to do, will run the Terraform plan. Okay, so before executing this command, I just want to make sure you are aware about this. In the left hand side, keep eyes on the S3 bucket where you can able to see the state log file will be automatically create tf.log file. .tflock file. So whenever the moment I execute this command, the file will be automatically create. So okay, I executed command, I refresh here. Okay, so now see the terraform.tf state .tf log file has been created. Okay, automatically. So now once this file is created, during execution of this command, this state is going to be logged by this file. Okay, so now again I am back to the main prompt where the command execution has been completed. So let's refresh again. Let's see what happened. So I refreshed on the S3 bucket. Can you see here that S3 TF log file has been deleted automatically because the execution has been completed. Now let's apply again the Terraform state, which will be create S3 bucket in the backend resource. S3 resource will be created in the backend, and same time we will be able to see here again the TF log file as well as TF state file. Okay, and the same time what I'm going to do, I'm going to execute the parallel session to check that if that log state is working or not. Okay, so this is first session we are going to executing from the Visual Studio Code terminal. So for the apply, okay, once I enter here, okay, it will wait for the confirmation, and if you refresh here, you can see again the TF log file has been created. Why? Because we are executing the command or executing this config, same config what we are created to deploy the S3 bucket. Okay, now before confirming S here or accepting that approval, I'm going to check now this TF log file has been created. Now this state is locked because still this command is getting executed until unless I accept this and approve it to create that S3 resource, and same time I am trying to create a session, right, another session to try to deploy the same. So if you can check, we are on same folder. Okay, if I go up, so I am in same folder. I am trying to deploy the same execution command and trying to apply the same from the another session I created from the command prompt. Terraform. So let's see what will happen. So technically, as this previous session has been locked by the state locking, now this session has to be denied to apply anything, right? So let's see what if we were true. Executed command here, Terraform apply parallelly. Okay, can you see here? So now it is denying to apply any state because it is saying it is already locked by this ID, session locking ID. Okay, and you cannot deploy or this state, right? So Terraform acquired a state lock to protect the state from being written, okay, by multiple users at the same time. Please resolve this issue above and try. Okay, so what it is recommending? It is recommending dot lock is equal to false. You can do it this way, so it will be not disable the locking, or you can complete this first and then try it. Okay, let's say approve this. I am in the middle of Visual Studio Code and approving this build, previous build. Okay, so now apply is completed, S3 bucket is created. Now again refresh. If you see the state, TF state has been created. Now log file also get deleted because the apply config has been apply execution command has been completed. Okay, so now come here, back here, right, and now try from this another session. I will click on apply. So it should be execute the command and say no changes since previous state. Okay, see, so now this previously it was giving the error because the already one file writing or config writing is in process, and it logged by the tf state log file. If you can see here, okay, tf state. So if I plan here, again run the plan, and the moment I enter here, so it should be create the tf state log file. If you see quickly, see here you can see the tf log file. Okay, so now it's initialized, and if I refresh here, it's gone, right? So now what I'm going to do, we'll do vice versa. Now here I'm going to execute the destroy command. Okay, destroy. Okay, sorry. Okay, I'll just execute the destroy command here, which will be delete that S3 bucket we will be creating. So if you can see, okay, now destroy command execution has created another tflock file, which is going to be destroy one source or one object. Okay, and now same time if I'm trying to do some another command execution on the same tf file, okay, so you'll be see the same thing, right? So it is state lock to protect the state from the being written by multiple user. Okay, got it? So this is how S3 native state locking going to be worked now. So now you can save your infrastructure money on deploying the DynamoDB tables for state locking, and you can use the same S3 bucket and folder for the state locking in future. Okay, thank you everyone. Thanks for your time to watching this video, and keep learning. Bye.